Chapter 21, Section 3. In this section, we're going to look at the different types of reactions. As it says, there are literally millions of chemical reactions that occur every day. Chemists have defined 5 main categories of chemical reactions, and you'll be responsible for these 5 different types: combustion, synthesis, decomposition, single displacement, and double displacement. If you've ever seen something burn, you've observed a combustion reaction. Our definition states that a combustion reaction occurs when a substance reacts with oxygen to produce energy in the form of heat and light. Pretty simple reaction and pretty simple to understand. Combustion reactions produce one or more products that contain the elements in the reactants. So what that means is that if you start with, say, wood on the left side, you're going to have part of that wood on the right side. In a synthesis reaction, 2 or more substances combine to form another substance. An example would be, if you had H plus O. Oops. Why did it disappear? H plus O2 produces H2O. And as you see, this isn't a balanced equation. To balance it, we need to put a coefficient of 2 there. And now we have 2 hydrogen and 2 oxygen here, 2 there. So we need a 2 here. This has to change to a coefficient of 4. So we have 4. This is the actual balanced equation for hydrogen plus oxygen yields 2 water parts. All right. So synthesis reaction: 2 or more substances, hydrogen plus oxygen, combine to form another substance. In this case, hydrogen plus oxygen combines to form water. The generalized formula for this type of reaction is as follows: A plus B yields or produces AB. A decomposition reaction is just the reverse of a synthesis. In this case, we have 2 substances coming together to form a third. A decomposition reaction occurs when one substance breaks down or decomposes into 2 or more substances. So as an example, we could say H2O. Okay. I don't know why that disappears. H2O decomposes into hydrogen plus oxygen. And of course, this is a simplified version of that equation. I don't have the, I didn't put in the I didn't balance the equation. Okay. General formula for a decomposition reaction can be expressed as follows: AB produces or breaks down into A plus B. Most decomposition reactions require the use of heat, light, or electricity. All right. When one element replaces another element in a compound, it's called a single displacement reaction. And this is how that would look. A single displacement reactions are described by the general equation: A plus BC produces or yields AC plus B. Like, good idea to get at least these descriptors down for the different types of reactions on a study guide again. Here you can see that the atom A displaces atom B to produce a new molecule, AC, a single displacement reaction. We can predict which metal will replace another using the diagram shown below, which lists metals according to how reactive they are. Again, gold, and this table, gold being the least reactive and lithium being the most reactive. And you remember from our demonstration in the class, when we combine lithium with water, it started on fire, so it's fairly reactive. And the other ones that we used in that reaction, in that experiment, were sodium, potassium, and of course lithium. Very reactive, gold being the least reactive. A metal will replace any less active metal. What that means is that sodium will replace aluminum, aluminum will replace zinc, and so forth. In a double displacement reaction, the positive ion of one compound replaces a positive ion of the other to form two new compounds. And the way this looks, a double displacement reaction takes place if a precipitate, water, or a gas forms when two ionic compounds in solution are combined. And we'll do a reaction in the future, a chemical, an experiment, where we produce a precipitate. And a precipitate is if you boil salt water down and you boil off the water and the salt is left, that's a precipitate. A precipitate is an insoluble compound that comes out of solution during this type of reaction. Generalized formula for this type of reaction is as follows. And again, double displacement. So AB plus CD produces or yields AD plus CB or plus BC. All right? Double displacement. Two parts of the formula, two parts of the compound are displaced. One characteristic that's common to many chemical reactions is the tendency of the substances to lose or gain electrons. Chemists use the term oxidation to describe the loss of electrons and the term reduction to describe the gain of electrons. Chemical reactions involving electron transfer of this sort often involve oxygen, which is very reactive, pulling electrons from metallic elements. Corrosion of metal is a visible result. And this material here surrounding these rivets is corrosion. Substance that gains an electron or electrons obviously becomes more negative, so we say it's reduced. On the other hand, a substance that loses an electron or electrons then becomes more positive, and we say it's oxidized. Electrons that were pulled from one atom were gained by another atom in a chemical reaction called reduction. Reduction, as it says, is a partnered oxidation. Two always work as a pair, which is commonly referred to as redox or a redox reaction. That concludes the lecture for section 1. Questions for section 3, excuse me. Questions for section 3. Question number 1. In a blank reaction, two or more substances to combine to form another substance. And what that would look like, if we were to draw it, would be A plus B produces A, B. And if we remember from the graphics, what type of reaction that is, you should have put synthesis. Answer is D. The generalized formula for synthesis is A plus B produces AB. And like I said before, it's a good idea to get these down because it's probably what you'll see on a test. I may have the actual elements such as H plus O produces H2O, or you may see it in this form. All right, a synthesis reaction. Question 2. The opposite of a synthesis reaction is a blank reaction, and in this case we'd have something like AB decomposes or yields A plus B. Oh, it disappeared. All right. This type of reaction, should have said, is a decomposition reaction. All right, let me erase that. Correct choice in this case would be, oops, decomposition. Letter C. Question 3, reaction in which the positive ion of one compound replaces the positive ion of the other to form two new compounds is the single replacement. And this would look like if we had A, B plus, I believe this is a single displacement, A, B is the reaction in which positive ion one compound replaces the positive ion of the other to form two new compounds. Nope, this would be plus CD produces, this is a double displacement, we would have A, D plus C, B, a double displacement reaction. All right, and that would be letter B. Answer is B. A double displacement takes place if a precipitate, water, or gas forms when the two ionic compounds in solution are combined. And that concludes the lecture for section 3.